This is a Pythagorean theorem, and Pythagorean theorem has to do with right triangles. Notice we have the 90-degree triangle here. 90-degree angle. So that makes this a right triangle. This is the formula for the Pythagorean theorem. Make sure you pick the C correctly. The C is the hypotenuse. It's the longest side. But don't go by what it looks like. Go to the 90-degree angle. Opposite the 90-degree angle, you'll always find the hypotenuse. The other sides are called the legs. So the hypotenuse is C, and the legs are A and B. So notice sometimes the Pythagorean theorem doesn't have just a right triangle. The right triangle is embedded or inside another figure. This is a rectangle, and they're identifying the right triangle within the rectangle. We're looking for this side. So we're looking for the size of the leg. We have this size of the leg. This would be the hypotenuse opposite the 90. So you take that 7 and put it where the C is. You take the A, you take the 5 and put it where the A is. And the X would be acting like the B. From here on, it's just simplifying. 7 squared is 49. 5 squared is 25. Move this 25 by subtracting. So it's 49 minus 25 is 24. Now take the square root of both sides, and you have x equaling square root of 24. If you notice, when you take the square root in math, you always should put a plus minus. So when you're working with the length, and this is the length, you always choose the positive square root. These are special triangles. The Pythagorean theorem can be used if it's a right triangle and two sides are already given. But sometimes only one side is given, so the Pythagorean theorem cannot be used. But if it's a 45-45 right triangle or a 30-60, as long as they give you one side, you could find the others. Notice that each of the sides, one way or the other, has an x. All the sides have an x. So suppose this was the right triangle they gave you, and it's a 30-60 right triangle. They gave me one side. So the Pythagorean theorem cannot work. Even though it's a right triangle, you should have two sides given, but only one side is given. But since this is a 30-60, you could use a setup for the 30-60. So if they gave me the 6, in other words, they gave me the side opposite the 30. The side opposite the 30 is called an x. So if the one opposite the 30 is x, and that x is everywhere, and that x happens to be a 6, then put the 6 wherever there's an x in the special triangle. Then simplify, and this is what it looks like. So now we know that this is your x, and this is the x of the question, and this is the y of the question. The converse of the Pythagorean theorem means the backwards, the reverse. Converse means you switch things around. The Pythagorean theorem says that if you have a right triangle, then this equation should be true. The converse would be that you put this first and this second. So notice I'm going to put this part, the one after the then, I'm going to put it after the if. And what it was after the if, I'm going to put it after the then. So if you could show that the three sides, after you square them and put them into this relationship, and it gives you an equal sign. If it gives you an equal sign after you plug in the three numbers and you square them, then you're dealing with the sides of a right triangle. This is a distance formula which can be derived from the Pythagorean theorem. And these little ones and twos that you see here, they're subscripts. Subscripts are just used for labeling. They're not involved in the computation. This is the way we use them. So if you have 2 points and you want to find the distance between these 2 points, you label it first, x1, y1, x2, y2. This could have been the ones and these could have been the twos. It doesn't matter, at the end you get the same answer. So now replace each one of those numbers in the respective locations. So the 1 is going to go where the x1 sub 1 is in the formula, and all the other ones the same way. For example, look at this. The y sub 2 is going to be the 6. So it's right here. So you replace them, you do your substitution, simplify, and we have a distance between these 2 points of square root of 32 units. You always take the positive square roots as you're working with length. Then we have the equation of a circle. The equation of a circle is the one you see here. This h and k are x and y center coordinates. So even though these are x and y, they call them h and k, just to let us know that it's the center point. So find the equation of a circle with the center. So if they're saying this is the center, then that means that 2 is the h and the negative 5 is the k. So plug them in where the formula says to plug them in. Notice the formulas have their negatives, and if the number has the negative, you have to include it also. So this first negative, this is a subtraction that's in the formula, and this is a negative, the number that's coming in. So negative times a negative is a positive. You simplify. 3 to the second is 9, and this would be the equation of the circle with this center and this radius. Notice where I put the radius. I put it where the r is, and then you square it. So 3 to the second is 9. Now we're going to surface area for right prisms. For previous sections, remember a prism is a polyhedron, a three-dimensional figure, where there are 2 parallel faces that are congruent. That makes it a prism. So notice this and this are parallel faces. This is a formula. If you know what the variables mean, the formula can be used very easily. The P is going to mean the perimeter of the base. This is the perimeter of the base. That means the distance around. The H is the height. This is the height. Any of these can be the height. Any of these edges can be the height. Notice the 90-degree angle. Height always carries a 90 degree. Plus 2 times capital B. The reason they have a capital B is because it's going to represent a base area. So in this case, it will be the area of this rectangle. So 16 is the perimeter, 4 plus 4 plus 4 plus 4. All these are 4s, 16. 4, this 4 is the height. Here's the height, here's the 4. Plus, here's the 2 from the formula. And this is the area of the base. 4 times 4 is the area of the base. Simplify, and you get a surface area of 96 square centimeters. Now we have the surface area of a cylinder. This is a right circular cylinder, right? Because this point that's on one of the circles to the opposite circle of the base has a 90-degree angle. So that's where the right comes, like the right angle, 90 degrees. This is a surface area formula. So you have the formula, you just replace the variables. So right here, we just need an R and an H. You replace them here, you replace the H, and you simplify. Notice that it says 2 times pi r squared. Pi r squared is the area of a circle, but since you have 2 circles, that's why it's 2 circles. This would be the lateral area, just the area around the cylinder on the sides.